everyone, this is Mrs. Pagan, and in today's lesson we're going to actually take some information, put it into a matrix, and then we're going to take application problems and use inverse matrices to solve for these problems. Alright, let's go ahead and get started. So in number 1 it says use matrices to organize the information. So all we're going to be doing is just organizing information. We're not doing solving in this case about the boys and the girls in a school. So there's the freshman class has 83 girls and 91 boys. The sophomore class has 67 girls and 72 boys. The junior class has 81 girls and 79 boys. The senior class has 75 girls and 75 boys. Please label your rows and columns appropriately. Alright, there's actually 2 ways you can organize this information. I'm going to go ahead and just kind of draw my matrix. And what I'm going to say is I'm going to put the girls first, ladies first, and then the boys second. Okay? And then what I'm going to do is label each one. So we have the freshman class. For the freshman class, we have 83 girls. So I make sure freshmen and girls line up. And then for the freshman class, the boys are 91. Next class is the sophomore class. We have 67 girls and 72 boys. For the junior class, we have 81 girls. I make sure the girls in the junior class line up like I said before, and 79 boys. And then for the senior class, we have 75 girls and 75 boys. So that's one way to organize that information. Now, some of you might have said, oh, I was going to put the girls or the boys for the rows and the classes in the columns, and that is completely okay. So another way to do this would be putting the girls and the boys as the row. So then what you would do is the freshman class has 83 girls and 91 boys. Sophomore class has 67 girls and 72 boys. The junior class has 81 girls and 79 boys. And then last but not least, the senior class has 75 girls and 75 boys. So those 2 are pretty much the same answer. It depends on what you envisioned as soon as I read the problems. Either one is a perfectly great way to organize this information that is provided to us. So great job on that. All right. Now we're going to go into example number 2. And in example number 2 says Best Buy sells older movies for $14.95 each, but they are now on sale for $12.95 each. If you bought 10 movies in the past few months and spent a total of $139.50, how many regular and sale price movies did you buy? Set up a system of equations and solve the system using inverse matrices. Okay, so first, there's 2 types of movies that we are buying. Okay, there's the ones that are older movies that are $14.95, and then there's the ones that are on sale, the $12.95. Okay, so we bought some at a earlier time and some at a later time while they were on sale. So we just want to know, well, how did we do this? Okay, so first thing we do is label our variables. So let's say that x equals the number of regular price movies. And let's say y equals the number of sale price movies. Okay, so we know a couple things. First, we know that we bought 10 movies total. So the number of regular price movies we bought plus the number of sale price movies we bought has to equal the number 10. Well, we also know that money stays together. And we know that the regular price movies that we got were $14.95 for each regular price movie, plus the $12.95 for each sale price equals what we say is the total amount that we paid. One thing that we recognize in math is same units tend to stick together throughout the the word problems and throughout the equation. So it's a good thing to keep in mind when you're trying to think, how do these equations combine together? Look, money, money, money kind of stuck together and made what I like to call a money equation. Okay, and the movies plus movies equals a 10 movies kind of makes sense because you're comparing movies to movies to movies. All right, let's keep going now. So this is our system of equations. And what we want to do is solve this using inverse matrices. Last time we actually set them up together and we even started the solving process, so we're going to do the same thing. I am going to, just to make sure that we know, I'm going to put my leading coefficients of 1 and 1 because that's what it means when we don't have anything. And now let's go into the setup. First thing we do is take the coefficients 1, 1, 1495, 1295. Alright. Second thing is our variable matrix. So we have an x first, y second, equals, and then we have the numbers that it's equal to, 10 and 139.50. Make sure everything looks good, and now we are ready to solve. Now, just to save some time, I am going to say this is matrix A, and this is matrix B. And then we know that A times x equals B. And what we're trying to do is get x by itself, so we're going to do A inverse on the left side, and x equals A inverse times B. Whatever we end up getting will kind of answer our question. So let's go ahead and input and use our calculator. Please go ahead and take your calculator if you have not done so already, because we really need it. Alright, let's go to second matrix, and you've done this so many times, you might be going way ahead of me, and that is completely okay with me. We're going to edit matrix A, so it is a 2 by 2, and we have 1, enter, 1495.95, enter, and 1295. Alright, and that should be good for matrix A. I like to double check. Looks good. Now let's go back to second matrix and edit matrix B. It is a 2 by 1. So now we have 10, the first entry, and 139.550 in the second one. Alright, let's press enter. Looks good. I just want to double check. Everything looks good. Alright, we're going to go ahead and quit out of here. Go to the home screen. My home screen is already cleared. You can clear yours if it's not. So now we're going to go to second matrix, get our matrix A inverse times, grab our matrix B, and the answer we get is 5. Now what does that mean? Well, that means that we bought 5 older movies at a regular price and 5 older movies at a sale price. Alright, so that's our total of 10 movies that we bought. So half of them were on sale and half of them were on regular price. So unfortunately we lost some money because we could have bought them all on sale, but that's okay. Okay, when we needed those movies, they weren't on sale. Alright, great job with this problem. Alright, we're going to go ahead and solve one more, and then I'll let you do the last one. So let's kind of look at it. A caterer is planning a party for 64 people. I like to highlight that. The customer has $150 to spend. That's money. And $39 pan of pasta feeds 14 people. So notice that I'm kind of circling my monies and highlighting or underlining my people. And a $12 sandwich tray feeds 6 people. How many pans of pasta and how many sandwich trays should the caterer make? Set up a system of equation and solve the system using inverse matrices. Alright, so first we know that there's 2 types of trays happening. So the first one, we'll say x, equals, this is the number of pan of pasta. that we want to order. Because ultimately the question says how many pans of pasta and how many sandwich trays. So we want to be able to answer that. What's the number of pans of pasta we have to order? Well, why? Let's make that the number of sandwich trays we're going to be ordering. Okay. And now we're going to write the equation. I'm going to stick with the dollars first, just because I see all the circle ones are our money, and I'm going to start writing the equation. Well, it costs $39 for each pan of pasta, which is my X, plus $12 for each sandwich tray, number of sandwich trays is our Y, equals a total of $150. I'm going to go ahead and put my dollar sign just to show you it's dollar, dollar, dollar kind of stuck together to make that equation. Alright, the other one is going to be what I like to call my people equation. People, people, people. Well, one pan of pasta feeds 14 people, so we can do 14 times the number of pans of pasta we get is going to give us the total people there, plus the 6 people for each sandwich tray equals 64 total people that we need. Okay, so that's kind of the people equation. Now that right there is our system of equations. Now all we have to do is, using inverses, solve this. So I'm going to go ahead and set up our matrices. Leading coefficients 39, 12, 14, and 6. Our variable matrix x and y equals, we have 150 on top, 64 in the bottom. So I'm just lining them up as I see it, x and y, and 150 and 64 as I see it. I mean, we've done this before, so I'm going a little bit faster. Now, I'm going to go ahead and label each one. So this will be my matrix A, matrix X equals matrix B. And the goal is to try to get X by itself. So we're going to inverse matrix A on both sides, making sure it's on the left side. Those cancel, and X equals A inverse times B. So let's go ahead and use our calculator to do the rest of the work. We're going to go to second matrix again, and we're going to edit our first matrix A. It is once again a 2 by 2, so I'll leave the dimensions there, but I'm going to change all the entries. 39, 12, 14, and 6. Alright, I just want to double check my entries, make sure they're good. Everything looks good. Now let's go to second matrix and now edit matrix B. This matrix has dimensions of 2 by 1 as well, so we're going to go ahead and just change the entries. 150, enter, and the last entry is 64. Alright, now that it looks like we changed everything, I'm going to second quit out of here, clear my home screen, and now I'm going to grab what I need. Matrix A I need, so I'm going to press enter, inverse times matrix B. Alright, the answer that we ended up getting is 2, 6. Now, what does that mean? You do have to explain to your reader what that means. Since X, the first number, is the number of pans, okay, we know the following. We can order 2 pan of pastas and 6 sandwich trays to be able to feed 64 people with $150. Okay, just to kind of summarize. Now, those of you that are asking yourselves, how did she know which one was which? Remember that X was the first number, so that goes with 2, and that's the number of pan of pasta. So I'm trying to match everything up. Y was the second one, and that goes with 6, and that was the sandwich trays. So always looking back on what those variables meant. Alright, well, great job today in today's lesson. I want you to go ahead and try number 4, please, and we'll go over to see if you got that correctly. Alright, great job today. Please don't forget to try example number 4.